Chapter 11, Day 6, we're going to go ahead and check out the area of regular polygons. So real quick, just as a reminder of what a regular polygon, in order to be a regular polygon, they have to have all congruent sides and all congruent angles. So if we look at this polygon down here, in order for it to be a regular one, all of the sides that make up the polygon have to be congruent, and also all of the angles would be. So if they're telling us it's a regular polygon, we can go ahead and use that information and apply this formula. The area formula for finding a regular polygon, whether it's a hexagon, pentagon, octagon, all things beyond the quadrilaterals that we already learned the area formula for, or the triangles or circles, the area formula for all these regular polygons is going to be 1/2 times little a, we're going to talk about what that is in a minute, times p. Okay? Now, remember, area is the capital A, so little a would be what's called the apothem. Let's go ahead and go back up to the top here, where it gives us a space to answer the apothem definition. The apothem is the distance from the center to a side of the polygon. The one thing you need to make sure is true, though, is that in order for it to be an apothem, it has to be perpendicular to that side. Okay? So if you want to think, you can look here at this hexagon, and this right here from the center to that side, making a 90-degree angle, this would be our apothem A. So if you want to think about it this way, when you're talking about a pentagon, hexagon, or anything larger, it's kind of like the radius. It looks like a radius. The only difference is, remember that a radius is that distance, but for a circle, it's consistent throughout the entire thing. So for a radius, that distance is the same no matter what. Whereas for this one, if I did that, the radius here would be the same, whereas the apothem, clearly, see how that's a little bit longer? So that's the difference, if you're curious, as an apothem versus a radius. So that's why it has a different name. P for this formula is the perimeter. Okay, so we want to make sure we know this formula. It's on that formula sheet that we gave you with the completed formulas, but that's how we find the area of a regular polygon, which again, we use when it is larger than 4 sides, because we have the formula for a parallelogram, any type of quadrilateral really. So let's go ahead and check out these 2 examples. We have example 1. This is a pentagon, right? It's got 5 sides. So in order to find the area for it, we want to go ahead and find the apothem, which we said right here, from the center to that regular side at 90 degrees. That's going to be our A value. Okay, so let's go ahead and copy down the formula. 1/2 A times P. Start plugging in what we know. 1/2 A is our 12. Now we just need to find P. Remember, P is the perimeter. Well, these formulas are only for regular polygons. And we just said at the beginning here, in order to be a regular polygon, all sides have to be congruent. So if they're giving us this one side is 8, right? Then all the other sides also have to be 8. So you can either add 8 5 times, or there are 5 sides. Each side is 8 inches. So if we multiply them, you have a total of 40 inches for the perimeter. Okay, so the perimeter, we're going to go ahead and mark, is 40 inches. Again, because it's not an area, so we're going to mark it as 40 just inches. And then we're going to go ahead and plug that in to help us find the area. In your calculator, you've gotten used to hopefully the calculator process here. 0.5 times 12 times 40. We get 240. So we get area equals 240. And then remember that because it's area, we are talking in inches squared. So let's go ahead and throw in the perimeter as a little bonus there to let them know that we not only know how to find the area, but we also know the perimeter because it was part of the process of finding that area. So that is the area, and the perimeter is that measurement around the outside. Number 2 is a triangle. Now, we already have a triangle formula, but in order to use the triangle formula, we have to have the full height, right? So notice here, if they give it to us that it's a regular polygon, we don't know the full height, but we do know the apothem. So I know I said that we typically use these for shapes that are not squares or triangles because we already have formulas for that, but there are cases here where it does actually help. So we have the apothem, which is 5.8. So I'm going to write out that formula again, A times P. Let's go ahead and fill in that apothem value that we know, which is 5.8. And now we just have to find the perimeter. So again, just like the last one, if it's a regular polygon, which we're going to state that these are because that's what the notes are on, all 3 of these sides have to be congruent. Meaning, if I want to find these 3 sides together, the other 2 have to be 20 as well. So we can do 20 times the 3 sides, and you get the total perimeter equal to 60. So we're going to go ahead and plug that in for P. And let's state that the perimeter, just because it's nice to know, is 60 centimeters. Remember, not squared because it's not an area. And then we can just go ahead and plug this into our calculator. 0.5 times 5.8 times 60, and you end up with 174. So the area here is going to be 174, and that would be centimeters squared. Remember, that's because it's area. It's got to be in units squared.